Welcome to our first video explaining what shading and solar access is in building design. First thing we've got obviously is our model here, which is a fully enclosed volume, so it's got nowhere for light to get in apart from our glazings where we intend it to penetrate. We've set our orientation down here with a little north arrow. Now what we'll do is turn on our sun path. So what we've got here is a sun path for the 1st of July. So the sun path is simply the trajectory that the sun's going to take through the sky. So 1st of July, which for the southern hemisphere is obviously winter. In southern regions of Australia, such as Melbourne, it is a heating climate. So we're looking, in this instance, to get as much sunlight as we can, and that's what we talk about solar access, what we mean. So we're looking to get it into the building, and for that solar radiation or solar energy to be absorbed by materials inside the building. So predominantly it's going to be our floor. At 9 o'clock we can see, we better turn on our shadows. At 9 o'clock we can see we're not getting much direct sunlight into the building. There'll still be some illumination in the building, but we're not getting direct sunlight striking objects inside the building. As we move on, let's run up to about, let's try 11 o'clock there. 11 o'clock we can see we're starting to get some sunlight come in, and we're particularly focusing on this main building, which is a living room. Over here we've got a bedroom, which is not of such importance to us because it's not a day occupied room. As we scroll on through, we're now at 12 o'clock, so we can see, and continuing on into the afternoon, we can see that we've got good solar access there. So we're getting plenty of sunlight come into that area, and it's going to warm up. Now if we have a good thermal mass material on our floor, it's actually going to store that heat energy and re-radiate it later in the afternoon as the temperatures come down. So just tracking along, we can see that even late into the afternoon, 4 o'clock, we've still got pretty good solar access. Okay, now if we flip to the opposite season, so we're going to go to January, 1st of January. Again, southern hemisphere, this is summer. You'll notice that the sun path has actually changed significantly. So it's now a much more upright sun path that comes up over the top of our building, which is what we'd expect in summer. We'll pull our sun starting time back to about 9 o'clock there. Let's just park it there. Okay, so the important thing we're looking for here now is we're looking to prevent sunlight, particularly during the mid and later hours of the day, from entering our building, because being summer, quite warm temperatures, we're looking to minimize the heat gain. Okay, so here in particular we're going to look at the effect of this, it's actually an adjustable Vagola in this building. So 9 o'clock, no dramas. Let's watch as we scroll through. Okay, we're now at about midday. If we zoom in a little bit, we'll find that pretty good shading through here, even reasonable shading outside the building. Let's scroll through a bit further in the day. We can find even at 2 o'clock in the afternoon, still quite well shaded. We do find by 3 o'clock we're starting to get some penetration of sunlight here, but the significance of that is probably not too great at the moment. The intensity is starting to fall away a little bit in the sun. We'd also find, particularly out here when we've got more entry into the building, that it's going to become difficult to shade this because the sun is now getting relatively low in the sky. So we've actually achieved reasonably good shading, made possible by our good north orientation, as we know from principles that north-facing windows are the easiest ones to shade in the southern hemisphere because the sun path in winter is so much lower than the sun path in summer. So that's a quick illustration of sun path diagrams and the importance of solar access and shading in building design.